Hey everybody, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine series. So in the last episode, what we did was we built a camera movement system so that we can now pan around our scene and then reset our camera. In this episode, we're going to be setting up the basis for our gizmo system. So when you click on an object, it will pop up the gizmos that you will use to translate and rotate and whatever with them. Now, currently, it's not actually working. We're just setting up this process first, and we will also be adding in a rotate function because I realized we don't even have a way to rotate sprites, and we really need a way to rotate sprites because that's a pretty important part of building games. So we will be building this little gizmo, the basis of it, and then we will go into depth on how to make it actually work in the next episode. Before we start talking about how this works, I do want to thank you all because I forgot to in the last episode for 700 subscribers. We are really close to 1,000 subscribers, and it would be really cool if we got there by the end of the year. So thank you so much for that. Now, let's go on with the tutorial and see how this gizmo system will work. So the gizmo system is pretty simple in essence. What we're going to be doing is basically creating some sort of system where when an active game object is selected, so when the user clicks on some game object, we basically just move two dummy game objects over here, which are the arrows. So the arrows just are another game object with a sprite. So basically these two things are game objects themselves, and we just store them inside of a class called a Translate Gizmo. And literally what we do is we just say if there is no active game object, then set the opacity to 0, so we just hide them. And then if there is an active game object, then turn the opacity back up to 1. Now, this is mostly simple, but there's a couple other things we have to do to get this working fully the way the engine works right now. And one of those things is rotation, because for some reason I never implemented rotation for our sprite batching. So in order to rotate a sprite, it's not that hard. If you have a sprite that looks like this, but you want to rotate it like this, currently what we do inside of our batch system is we add each vertex to the batch. And so normally if you had rotation or something, you could do that on the GPU using a transformation matrix. But since we're batching, we have to do this on the CPU side with our transformation matrix. So we basically check and see if the rotation is not 0. So if it's something like 45 degrees, we construct a transformation matrix using the translation, rotation, and scale. And we want to make sure that we are rotating about the z-axis. So we just want to make sure we're rotating about this axis since we are working in 2D. Then when we create this matrix, we can literally just multiply this matrix by these points. So if we multiply this matrix by each of these points, in this case it would just be like some vertex, then this will transform the vertex to the appropriate position. We're sort of doing this manually, but we'll just explicitly do it for rotation matrices. The reason that we don't use a matrix when we're building the regular one is because it's a little bit more expensive to do matrix multiplication than it is just to do one regular multiplication, which we can do. And I'll show you more of what that means when we actually get into the code and look at that. Now, I will also admit that the system we're going to be using for this is not the greatest, and that's because we don't have an event system right now. That will be like the next step because we need a general event system to be able to pass events around our game engine, because right now it's really hard to tell somebody what the active game object who wants to know without creating some ridiculous chain of dependencies, which is what we're going to be doing in this episode. All right, but with that brief intro, let's actually go into it and just sort of create this Translate Gizmo class, which will hold a couple of game objects, which are actually going to be the arrows, and then we'll just sort of set the transforms to the active game object. Okay, let's check this out. All right, just to reiterate, where we left off was we just have this camera, which we can move around, zoom out, zoom in, and recenter using a hotkey of your choice. And we have picking enabled. So using the picking, we will be able to implement this gizmo system to sort of place the gizmos on the active game object. Okay, so let's go ahead and create a new class inside of our components, and we will call this our Translate Gizmo. So the Translate Gizmo will just extend component because we just want another component, and we'll have a few different variables in here. We're going to have a lot of variables in here. So we'll have a vector4f for the colors. We'll say this is the x-axis color, and I'm going to create a new vector4f, and we're just going to color this red. And then we'll have vector4f x-axis color hover, which we don't actually use yet, so I'm just going to leave that uninitialized, and we'll tweak it when we get around to it. And then we'll also have a vector 4f, y-axis color equals a new vector 4f. This one will be blue. And we will have a vector 4f, y-axis color hover. And this will just be a new vector 4f. And let's just copy that and paste it so that I get rid of that typo. Okay, so then we're going to need a couple more. Like I said, we want to actually create game objects and sort of move these game objects around, and these game objects will store it. I wouldn't do this normally. It's just not ideal. But the way we have our render batch working right now, we can only really add images, which is what those arrows are for the gizmos. We can only add them by using sprite renders that are attached to game objects. Because when we load the sprite render, we automatically assume that once we get into here, that sprite render will be attached to a game object. So there's no really a way to beat around this bush unless we go and do some extensive refactoring of the render batch, which we may do in a future tutorial, because that's what I did on my actual game engine that I'm working on the side. But for now, we'll do it this way, and this way works. So we'll just do it this way. So let's create a game object, and we will call this the x-axis object. So this is going to be the object holding the x-axis little gizmo arrow. And then we'll create another game object, and this is the y-axis object. Once again, just holding the little arrow. We're also going to get a hold of their sprite renders. So we'll call this x-axis sprite, and we will also get the y sprite. So y-axis sprite. And then we will store a reference to an active game object. So we'll say active game object, and this is what we will use to determine where to place those objects. And it's just going to be null initially because we don't know what it is. Okay, and then finally, we're going to need a reference to the properties window. We'll wait on that though, and we'll see why we need that in a minute. Okay, so anyways, let's go ahead and say public translate gizmo, and this will take in a sprite, and we'll just call that the arrow sprite. And so the arrow sprite actually looks like a very simple sprite. Let me pull it up real quick. All right, so this is the gizmos.png image I have, and you can see that the arrow sprite is just literally an arrow, and then there's a square which we'll use for like the free transform, whatever. And you'll also notice they're white. That way we can tint it whatever colors we want and not have to worry about that. You'll be able to grab this at the link in the description, check it out, and you can get this picture, or you can use whatever picture you want. Just make sure that you do place it inside of our assets directory. This is important. You need to have an assets directory with the images, and make sure your file paths are correct, because otherwise you will have problems if you can't find the correct file. Okay, so we will get that arrow sprite, which is part of that sprite sheet, and we'll just pass it in here, and then we'll say this.x-axis object equals prefabs.generate sprite object, and we'll just use that arrow sprite, and I think it's 1648 is the size we're going to use. So we'll say 16 by 48. That is its actual height and stuff. So just make sure you have that right so that you don't get any weird stretching. And then we will do another one for the y-axis object, and we'll say 16 by 48 as well. Then we'll say this.x-axis sprite equals the x-axis object dot get component sprite render dot class. And then same thing for y-axis sprite equals y-axis object dot get component sprite render dot class. All right, a lot of code duplication in this. It could probably be avoided, but it's enough. It's little enough that I don't really care. Okay, and then lastly, we will add these objects to our scene. So we'll say window.getScene to add game object, and then we'll add the x-axis object, and I'll just duplicate that, and then y-axis object as well. So we create game objects, we add them to the scene. That's a good first step. They take in a sprite, so they're going to have some sort of sprite. Now we basically just want to make sure that it gets put in the position of the active game object whenever there's an active game object, right? So we'll go at override, public void update, take in delta time. Then we'll basically just want to say if this.activeGameObject does not equal null, we'll just set the gizmos to the object's position. So we'll say this.x-axis object.transform.position.set this.activeGameObject.transform.position. And then duplicate that, and we will do the same thing for the y-axis. Now clearly this is not going to be the correct location because they'll be overlaid right on top of each other and everything. And we'll see how to get around that in just a moment as well. Now, we'll also need a couple functions that will just be helper functions to set it as active and set as inactive. And so we'll just take in a game object, object, and we'll say this dot active game object equals object. And then we'll just say this dot x-axis sprite dot set color. And then we'll set it to the x-axis color. This dot y-axis sprite dot set color to the y-axis color. And then when we set it as inactive, we basically just want to make sure that they are invisible. So we'll set the opacity to 0. So we'll say set inactive, and then this will just say this dot active game object equals null, thus making sure that we're not replacing them and stuff. And we'll say this dot x-axis sprite dot set color, and then we'll just say 0, 0, 0, 0. Well, we can't do that. We have to pass in a vector 4. So say new vector for f 0, 0, 0, 0. And then I'll duplicate that, and we will also set the y-axis. Control D to duplicate, by the way. All right, so we have these helper functions and everything, and this looks pretty good. Let's go into our level editor scene and get it set up so that we can at least have it sort of working. All right, so inside our level editor scene, I'm going to scroll down to where we're loading resources, and we're going to have to load the sprite sheet that we just created. So I'm going to say load sprite sheet, asset slash images slash gizmos.png is the location to mine. And we're going to say this is a new sprite sheet, asset pool.get texture. We really need to change this too because this is a mouthful. Same path. And then we will also give it the sprite width, which is 24. The sprite height is 48. And the number of sprites is 2 and spacing is 0. In my case, you may have a different sprite, in which case you'll just do it as appropriate for your image. Then we're going to go ahead and actually move these two things all the way to the top of this function because we will need the sprite sheet image when we go to create the sprite sheet object. So I'm going to go ahead and say sprite sheet gizmos equals asset pool.get sprite sheet, and just the same path again, images slash gizmos.png. Now that we have the sprite sheet, we can actually add it to our level editor stuff component or game object. So we'll just say add component, new gizmo, translate gizmo, and then just pass it the arrow sprite, which is gizmos.getSprite1. Okay, cool. So now we have it added to our scene. It should be working, sort of. And our level editor stuff is being updated right now, and we will also add it in to be IMGUI, because we will need that. So I'm going to say imgui.begin, and then I'm just going to say level editor stuff. Then we're going to say level editor stuff.imgui and imgui.end. This is just because we'll be using this for debug stuff. You can remove this at some later point too. Okay, so if we run this now, we're just going to get no errors, but nothing's really going to happen, and we don't really see the gizmos because we don't know what's happening. And this is our level editor stuff too. I didn't realize that we would have all these other things available to us too, which is kind of cool. But yeah, and so you can see we'll even be able to edit the colors and stuff. Okay, that's besides the point. Anyways, let's go back into our thing and actually make this work. So right now, how do we get the active game object? Well, the active game object is set in the properties window whenever you click on something. So I'm going to create a function in here and say public game object get active game object and just return this active game object. This is definitely not the best way to do this, but it's the easiest way to get this to work right now. Then we'll just go into here and we'll create a dependency. We'll say this takes in the properties window, and we will just say up here, private properties window. We'll just take a reference to that and then set it in here. So we're going to have to hook up this dependency in just a second, but this way we actually at least have a reference to it. And then inside of our update method, we can just say if we can say this active game object equals this properties window get active game object, and then we can just say if this active game object does not equal null, then this set active, and then we don't even need to pass it in at this point because it's already there. So we'll just get rid of that, and then we'll say else this set inactive. All right. So now basically what we're doing is we're just getting the active game object from the properties window, and then if it's not null, we set it as active. If it is null, we set it as inactive. So this should sort of set it in the correct location. Let's go ahead real quick too and override the start method. We'll just say public void start because we will need this in a minute too. So we at least have that there. Okay, now let's hook up the dependency for the properties window. So if we go back into level editor scene, we'll notice that it says that we have an error because we're trying to create this, yet we don't really have the properties window. So I'm going to go into here and then just say window.get window or get.get properties, or actually we'll say .get IamGUI layer.get properties window. And this is why this is not good. Like, you shouldn't be creating functions like this. And so this is how you know this is a bad design. But until we get an event system, this is the best way to do it. So to be continued once we get an event system. Let's go into our window class now. And we'll go down here and just create a public IamGUI layer, get IamGUI layer, return get.IamGUI layer. And this will be static. Okay, so now that function is done. And then we will go into IamGUI layer and we'll say, all the way at the bottom here, just create a getter, public, and this will be the properties window, get properties window, return this dot properties window. All right. And then if we go back into level editor scene, this should be good. So if we just change this from window.get to window.get IamGUI layer, .get properties window. Okay, so we're all good there. And we just have to make sure we're passing it into the right place. And I'll move this parenthesis. So now if we run this, we should see that if we click onto an object, okay, yeah, you see we get the green arrow and the red arrow is behind it, but we can't really see it. So it moves to where we're clicking, but we need to rotate these sprites now. So like I said, we have to modify our render batch to allow rotation and our transform class. I can't believe that I did not do this because this is a really important part. So let's go into transform class and then we'll say public float rotation. We're going to add a rotation and it's going to be initially set to 0. Then we will go into our render batch and we will fix this up to actually use this rotation. So inside of our load vertex properties method, we'll multiply by the transformation matrix if we need to. So we'll say boolean is rotated equals sprite game object transform rotation does not equal 0. So if it's not 0, then it is rotated. Then we'll say matrix for f transform matrix, and we're going to just set this to the identity matrix for now. And then if it's rotated, then we'll construct the actual matrix. We'll say transform matrix dot translate by the sprites game objects transforms position. And this actually needs to be 3 numbers because we need a vector 3 for a transform matrix. So then we'll just say sprite game object transform position y. And then if we look at the parameters, it expects a z and a w, which I think, oh no, we can leave out the w. So we'll just do x, y, and z. And make sure you do translate, not transform. Okay, so then we'll say transform matrix dot rotate, and we want to do float math dot to radians. So we're going to convert the degrees to radians. If you have it in radians initially, then just leave it there. So we'll say the rotation of our sprite object, and then you'll see that this also expects an axis. So we can just say 0, 0, 1, rotate it about the z-axis. That way we get the 2D rotation. And then we want to scale it. So we'll say transform matrix dot scale, and we'll scale it by the sprites transform scale x, sprite transform scale transform game object transform scale y, and z will say 0, and then for w, or we don't have to worry about w again. Okay, and actually I'm going to do z as 1 just so that we're not getting any weird numbers in that transformation matrix. Okay, so now we have a transformation matrix if it is rotated. Now we will go into where we actually load the position right here. So this is the only thing we really have to change. So what I'm going to do is I'm going to say vector for f current pose equals a new vector for f. And then I'm going to go ahead and copy this big line. So copy that whole thing, put it in there for the first parameter, then copy this one, and then put it in there for the second parameter, so x and y, and then we'll do 0 and 1. All right, so basically we're just putting this into the x position of this vector, this into the y position of the current vector, and then we're setting z to 0 and w to 1. Then we'll just say this is current pose.x, and this is current pose.y. Okay, so we're just sort of refactoring a little bit there, but this will make it easier if it is rotated. And I'll move this stuff down here too, just so you guys can see that. Okay, then we'll say if it is rotated, we have to actually multiply this position by the transformation matrix. So we can simply do that now just by saying current position equals, and then we'll say new vector for f, x add, y add 0, 1 dot multiply by the transform matrix. All right, so basically what ends up happening is if it's not rotated, we do the exact same thing we did before. But if it is rotated, then we just get x add and y add, which are these, and then we transform them according to this game object's position, scale, and rotation, which will give us the correctly created coordinates and everything. So it's simple, it's kind of dirty, but it works once again. So this should give us rotation, okay? Let's see if it works by going into our Translate Gizmo now, and then inside the start method, we'll just say that the x-axis object dot transform dot rotation equals 90 degrees. So if we do that, we should see it rotated 90 degrees. And if I click, we are not getting that. So let's see what's going on there. Oh, and that's because the start method is never being called. Let's go into level editor scene real quick and make sure we actually call this start method. So this is part of the level editor stuff object, which isn't part of the normal object. So after we init everything, we'll just make sure that we call level editor stuff.start. Okay, now if we run this again, we should see that it hopefully works. So, okay, there we go. It is rotated. It works. That's good. You'll also notice that it's saving these, and that's a problem we'll look at in just a minute too, which we will fix. Anyways, let's fix the y12 just so that that is pointing the right direction. So inside of the transform gizmo, translate gizmo, we'll just say this dot y-axis object dot transform dot rotation equals 180. So we'll flip that upside down, and now there we go. We get it saved. Okay, now speaking of these weird things, why are they sticking around? Well, notice, so if I go over here, I exit, when I come back, we have another one, and it's right there. And then I click, and it starts moving around again. What's happening? Well, it's being saved. Why is it being saved? Because we added it to the scene. So it's just automatically saving these objects, but we don't actually want to save these objects. So we're going to create a new function called set no serialize. So basically, we can say set no serialize on an object, and this will make sure that it does not get serialized. So we'll just go into GameObject real quick, create this function, scroll all the way down. We'll just say public void set no serialize, and we'll say this dot do serialization equals false. Then we'll go up to the top, create a private boolean do serialization equals true by default. So by default, all objects are serialized. You can tell it to not serialize objects though. And then we'll just go ahead and say public void do serialization. And then we'll just say return this dot do serialization and make sure that we return a boolean. Okay, cool. So now we have to actually make it so that it doesn't serialize things if we don't want to serialize them. So we can go into the scene class, and inside of our save exit function right here, what happens is we automatically just serialize all of the game objects. So we want to say no, we just want to serialize game objects that want to be serialized. So we'll go over here and we'll just say list of game objects objs to serialize equals a new array list, and then we'll just say for game object obj in this dot game objects, if obj dot do serialization, then we'll say objs to serialize to add obj. Then instead of serializing the game objects, we'll just serialize the objects that we want to serialize. So we'll say serialize objs to serialize. This should fix our problem. If we go into here and then say we created Gizmo there, if we go back in, then you'll notice that that was not saved. Okay, cool. So that fixes it. How do we get rid of all the ones that did accidentally save? Well, we can just go into our level.txt, delete that, rerun this. Okay, so now we have nothing, but if we add stuff in, we will go ahead and add a few objects, and then we'll just click on one. If we reload, then we'll notice that it did not save that. Okay, there we go. So that's fixed too now. Now we have to do just a couple more things too. Also, notice what's cool. If we just tweak this, it's actually tweaking the object. And I don't really like the way that it changes so fast, but you can actually tweak the colors and stuff right up here. So if you want to change the colors and see how it looks, then you can do that. Okay, anyways, we want to make sure that these are lined up correctly. So we can do that very simply. Just go back into the Translate Gizmo. And then we'll just create 2 more variables. We'll say private vector2f x-axis offset equals new vector2f. We'll say private vector2f y-axis offset equals a new vector2f. Then we can go down here and just right after we add the position, we'll just say this dot x-axis object dot transform dot position dot add, and then we'll say this dot x-axis offset. Copy that, and then we'll do the same thing for y's and for y there. So this will just add an offset to the position. So now if we go back in, we'll notice that it looks the same, but we have those variables should pop up. Okay, so the variables do not pop up. Why is it not showing the vector2? Well, that's because if we go into our GameObject.imGUI, so if we just go into GameObject, or no, if we go into component, and then we go into the imGUI method. Okay, here we go. So this is why it's not showing up, because we have type equals int, float, boolean, vector3, vector4. We do not have vector2. Let's add in vector2. So we'll say else if type equals vector2f.class. And then I'm going to go ahead and just bracket that, delete that, and fix this formatting real quick. Okay, and then if it's a vector2f class, I'm just going to copy this. And we'll say vector2f val equals vector2f value. And then we will just get rid of that. Get rid of that. And change this to a drag float 2. All right, so this is inside a component. Now if we go back in, we should be able to tweak those. Okay, cool. So now you'll notice that says y-axis and x-axis offset. So if we move this, you'll notice that's actually moving the x-axis in there. And then I'm going to move the y-axis up and just find a place that you like. All right, and so I think it looks pretty good there. And you'll notice that it will now retain that position no matter what. So this is just a quick and easy way to sort of debug your stuff. So 64, -5, 15, 61. We'll go back into our Translate Gizmo. And that was 64, -5, 16, -1, something like that. Check and see if that looks right. Okay, that's another problem we're going to have to fix in just a minute. Why did it fly away like that? We'll check it out in a minute. Okay, so change that to 60, 1660. Oh, that must have been 61. Okay. So that's good. Now, why is it doing this weird thing? If you click and hold the mouse button, it kind of glitches and then flies away. Why is it doing that? That's the last thing we have to fix, and that's just because if we go to our properties window, and when we're setting it, we just say if mouse button down. We don't actually have a debounce time in here, so we'll just add a debounce. So we'll say float debounce time, or float debounce, and I'm going to set that to 0.2f, so 0.2 seconds. And then we'll say if, or we'll say debounce minus equals dt, and then we will just add in and debounce is less than or equal to, or just less than 0. Then inside here, we'll say this dot debounce equals 0.2f. Okay, so adding in that debounce, we'll just make sure that it doesn't glitch back and forth. And so if we click on these, it does it. And if you click and hold, then there is no glitching. The reason it was doing that was because it's sending out an event every single frame. And so it was just bouncing back and forth because it was setting it to null, then setting it to not null. So yeah, this works good. The debounce works, and we have our gizmos. All right, so this episode was kind of long. They've all been kind of long lately. Sorry about that. I hope you guys enjoyed it. If you did, please hit like and subscribe. And once again, just thank you for getting us to, we're at 750 subscribers now, just about. So really cool. Thank you so much. Sorry about the lack of videos too. I've been having some PC troubles this last week and had to install a new cooler and everything, which was a big hassle. But I should be good now. I'm going to try and start releasing again twice a week. We'll see about that. So you can expect like the next follow episode to this to come out Wednesday, hopefully. Anyways, thank you for watching. I'll see you guys next time.